We are Team 8-Bit, and this is our CSC 131 final project presentation. Purpose of the application. This application's purpose is to allow the user to input medical result for the patient's or other doctor to view over time and provide the patient with a possible diagnosis. The main target of this application is to indicate if the patient has Alzheimer's or not from the MRI test result inserted by the doctors. UML diagrams. The use case diagram and activity diagrams are created to depict the interaction between users and the app at various stages in order to demonstrate the program's basic flow, which has an impact on many interface designs such as efficiency. The user is logged into the Alt app, and the actors are medical professional, users, and administrator according to the use case diagram. The basic flow entails entering personal and medical information on several screens of the application, as well as an extension to import an MRI report and a post-condition to acquire an Alzheimer's disease diagnosis.
Class and sequence diagram. Other UML diagrams are used to illustrate the sprint's tasks, such as class and sequence diagrams. The sequence diagram and the class diagram are used to depict the sequence of events and how different classes interact with one another. This is how it looks, the class diagram for a project. We create an interface called hospital and four other abstract classes. The first one is patient info, medical record, MRI pass, and image content. As you can see, the interface has a multiplicity of 0 to 1, and the rest of the classes have multiplicity of 0 to many. Now I'm going to explain risk management. The predictable risk of people is the loss of a team member due to vacation or sickness. The predictable risk of a process is when the app is malfunctioning and being unable to process patients' values. The predictable risk of a product is when the application is being unable to provide accurate diagnosis based on patient medical information. The unpredictable risk of people is when there are workplace incidents or injuries. The unpredictable risk of a process is when there are incompatibilities between hardware and software, causing the application to fail. And the unpredictable risk of a product is when the patient values are being out of the range and impossible for app to handle.
The program began with the simple action of using a drag and drop interface to design the graphics of the app. So initially we created two simple layouts to serve as a screen on which users would be able to give their input. Following familiarity with these basic graphic components such as text boxes, subtitles, button, and images, we also decided what type of layouts to use. In order to accommodate the different functions of the app, we use relative layouts, which are layouts that automatically position objects relative to each other to ensure that the page is overall symmetrical and will not shift around. When we ran the application, our team was able to enter medical test information into the app after clicking through the Get Starting screens. We were also able to click on the next button and access the next page in order to upload the MRI images to the application. Finally, we were also able to create text views to label each boxes for entering in medical information according to the story map.
Hello class, my name is Russell Frost. Our team utilized GitHub so we could all collaborate. The app console was submitted to GitHub in two parts, the .java file, which contains the code for the app's functionality, and the .xml file, which contains the graphic aspect of the app. The design tab of the .xml file contains the XML code that determines the layout and organization of the various elements on screen. Linear layouts provide you more control over where buttons and text appear on the app screen by allowing you to quickly drag and drop items onto the screen. Using this layout type in the .xml file, four layouts that display on screen were constructed. Basic visual elements such as text buttons, captions, buttons, and photos are all included in the design, and each graphic element is linked to the primary code. The team was able to efficiently collaborate on all of this through GitHub. The main code of the program is saved in the .java file, while the graphics-related data like height, text size, and weight are all preserved in the first .xml file. Then the content is imported into the library. The majority of the Java code will be used to run the buttons and build the medical report at the conclusion, as well as apply an external app activity permissions and save them in a second file, the manifest.xml file. The software then can use an external PDF viewer that is already installed on the phone. The Scrum process. Scrum is an organizational framework that allows teams to increment through a complex software that a product owner wants created. The people involved in the process are product owner, Scrum Master, the Scrum team, and all the stakeholders. The product owner creates a product backlog board that clearly states everything that is needed to be a part of the software. Next, the Scrum Master can be viewed as a strong leader that will lead the Scrum team through their sprint. A sprint is a set period of time where the Scrum team members work on increments to the software that they choose during the sprint planning stage. After the sprint, there is a sprint review, which aims to examine the outcome of the sprint, and a sprint retrospective, which aims to think of ways to better the outcome of the sprint. The Scrum approach was employed by our team throughout the creation of the Alzheimer's app. The roles of the product owner and Scrum Master were rotated among each team members during each sprint. Based on the epic, user stories and a product backlog were created. On the board, there were tasks to accomplish, review, and complete.
Sprint process. The sprint planning included the layout of numerous UI components in XML files, as well as their implementation in Java. The sprint review included changing the visibility of each screen and developing a shippable product at the end of each sprint. During each sprint, different team members held and recorded meetings to discuss the goals, challenges, and upcoming work. Team members established the approval criteria and the concept of done. Based on the completion of the screenings and the development of the Alzheimer diagnosis report, a sprint burnt-down chart was created for each sprint. Jira. The Alzheimer's app development project is a Scrum project with a story map, and it has an open access for all team members. The project was completed in 3 sprints. The Jira board was used to represent the typical workflow of creating all the screens and the implementation in each sprint. The Jira board also displayed tasks that were in process, under review, or completed. The team used Jira to navigate through the Scrum process while developing our application. High cohesion and low coupling in applications. High cohesion refers to the principle of not having methods perform too many tasks. By having specific modules do certain tasks, this promotes the reuse of code and is easy to maintain. High cohesion also represents how closely methods or classes work together. An example within our application would be when the medical results are entered, that information would then be saved and used when needed in other classes or modules. Low coupling refers to modules and classes being more independent by themselves and not dependent on other methods or classes in order to work. An example of no coupling within our application would be buttons with specific functions, such as the next button. These buttons basically have their own modules, but do not require other information, such as the patient's medical information. These buttons can retrieve information, but that is as far as they go.
Architectural styles. In my app development, I employ Model View Controller or MVC, one of the most prominent architectural patterns. Setting up your project on Android is simple. The data classes are objects that model the real world, such as users or products. This category includes visual classes, which are what the user sees. In the case of Android, it's mostly XML. However, you can also construct views in code using the manifest XML glue. It changes the model, updates the view, and takes users' input. Organizing your code into these three categories can help it become more decoupled and reusable, keeping your view layer tidy by transferring as much layout and resource functionality as possible into Android XML. Running Espresso tests on the UI. Our team uses the Espresso UI test which is a user experience built for single app testing and interaction to test our JUnit for testing UI-based application. The team generates test case in a special for each class and its specific features ensuring that all JUnit tests succeed significant code coverage and that the code was correctly covered while reconstructing ECLMR. The special framework to automate the user interface test case that include IDs of text and buttons in the Java class by clicking buttons. The approach includes preloading the configuration, closing soft keyboard, and tearing down all resources following the test. Introduction design. The app only has basic minimum of information to allow users to submit personal and medical information on the necessary pages, and the user interface is straightforward to understand and use, resulting in patients' Alzheimer's PDF report. So now let's talk about the different aspects of introduction design. Accessibility. The user needs to click next on the given construction button to proceed to the next page. Consistency. The app design is consistent because each page has a standard font for titles. Contrast. The button in gray and the tops of the app in blue are clearly distinguished from the usual text by the size, typeface, and color. On each page, there is a red line separating the last entry from the button. Recovery. The app can swiftly recover from any faults that the user encounters, making it user-friendly and error.
Alright, so in our project, the decorator pattern was used to add attributes and action to arbitrary class instances at runtime, as well as to add different collections of attributes and activities without having to create a complicated class hierarchy. As we can see here, it seems complicated, but it's really not. The decorator component interface was also used to override component activities and add their own characteristics and operations. And then next is the singleton design pattern, which we also used. We use this because it's one of the simplest design patterns in Java, because the only goal for the singleton design pattern is to create one single object, as we can see here. And next we have the team comments. So as for team comments, we realized that Scrum is a really hard topic to master, as mentioned in the beginning of the semester by the professor. What we found hard is that the more people you have, the harder it is to manage and communicate, especially during school. It's gonna be different for us in the during our career path, because we have different factors in school, like different classes and maybe a job. Um, yeah. Next is the testing user interfaces. So the professor provided JUnit and ECL Emma, but we also used one that's called Espresso, which is made specifically for Android testing, which we were using to develop our application. And next, during the whole Scrum process, we realized that sprints can be really fun. It's an easier way to manage and assign tasks to people. It's better than just saying assigning on a group chat and then no one people won't remember what they got assigned. This is an easy way to follow what you got assigned. And as mentioned before, time management and communication is really important. And there are different techniques and principles to follow when developing software applications. For example, the use of high cohesion and low coupling. That's a really important technique that we should use and follow in our career. And yeah, that's pretty much it.
We were able to develop an app for Alzheimer's patients that provides quick access to personalized medical information, as well as breakdown of particular elements that may be contributing to any memory loss. The Android programming-based project provided us an opportunity to learn about the Agile method, different software engineering principles, GitHub, creating multiple UML diagrams, and also learning about design patterns. It was fantastic to use Jira capabilities like burn down charts, sprints, and role rotation. Our app also employed automated testing, and it was a really good learning opportunity. Thank you.